Hello and welcome to lesson 3.8. Today we're going to look at finding and estimating square roots. So by the end we're going to be able to find and know what a square root is, and we'll be able to estimate and use other square roots to help us approximate other square roots. So to begin with, I want to just kind of talk about a couple little examples here. So for this first part here where we have 11 squared, we know that this is really 11 times 11 or 121. Likewise, if I take a negative 12 and I square that, really I have a negative 12 times a negative 12, and because I have a negative times a negative, this will give me a positive, and 12 times 12 then is 144. So in both of these cases, I'm actually multiplying the number by itself to produce a positive number. So I could have a positive times a positive, which will give me a positive, or I can do a negative times a negative, which will also give me a positive. Okay, so my next question is going to be, how do we undo the squaring function? Okay, so we know that 11 times 11 is equal to 121, and we know a negative 12 times a negative 12 is 144, but what if I ask you, what is a number times itself that gives me 144? Would you be able to answer that? Okay, and in this case, if you can't answer it, that's what we're going to talk about in this section. And in this section, we're going to talk about using what we call a square root. Okay, and the symbol that we're going to use for a square root looks something like this. So by textbook, the definition of a square root says the number a is a square root of b if a squared equals b. So again, we have 4 squared equals 16, and I can also have a negative 4 and square that and get a 16. So we would say that a positive 4 and a negative 4 are square roots of 16. Now sometimes we might even show it as plus or minus 4 to show that there are really 2 solutions. So every positive number has 2 square roots. Okay, I want you to keep that in mind, please. So as we mentioned a few slides ago, a radical symbol, which is what this is right here, this indicates that we're trying to find a square root. When we find the positive square root, this is what we call the principal square root. So the principal square root is kind of the one that you use most often, okay? However, unless you're told otherwise, when you take the square root of something, you need to list both solutions, the positive and the negative. The expression that's on the radical sign is called the radicand. So whatever you put in this little spot down here inside of the square root, that is your radicand. So now when we solve these, we want to know what the square root of 64 is. So how we're going to interpret this is we're going to say that what number times itself will give me 64. So if I think about the positive aspect, 8 times 8 gives me 64, but a negative 8 times a negative 8 will also give me 64. So in this case, it will be a positive or a negative 8. Likewise, for part B, the square root of 100 is going to be 10, because 10 times 10 is 100, but I do have that negative in front, which tells me that we are only interested in the negative side of that answer. For part C, I have the positive and negative of the square root of 9/16. Well, with the square root, because I have this over a fraction, I can actually break that up into the square root of 9 divided by the square root of 16. So this is going to give me an answer of plus or minus. The square root of 9 is going to be 3 times 3 is 9, so I'm going to have 3, and then I'm going to divide that by the square root of 16. Well, 4 times 4 gives me 16, so I end up with a positive, or plus or minus 3/4. Now for part D, it says plus or minus the square root of 0. Well, there's only one answer for the square root of 0, and that is 0, because 0 can't be positive or negative. And then finally, we have the square root of a negative number. Well, if you stop and think about this for a second, there's no number that you can multiply by itself with the same sign that will give you a negative number. So negative 4 times negative 4 is going to give me a positive 4. A positive 4 times a positive 4 is going to give me a positive 4. So in this case, I'm going to say that this is undefined. I cannot take the square root of a negative number, and it's all undefined because of that negative sign right there. Now what you're going to see when we do some examples here is that some square roots are rational, and remember, a rational number is a number that terminates or repeats, and some are going to be irrational, or meaning that it does not repeat. Okay, and we'll take a look at a few of those. I will show you in class where that square root button is on your calculator too. But I would like for you to know the basic perfect squares so that you can do some square roots in your head. So for example 2, it says tell whether each expression is rational or irrational. So I have plus or minus the square root of 81. Well, the square root of 81 is going to give me 9, so I have plus or minus 9. So this is going to be a rational number. Now for the next part, I have the negative square root is all that I'm interested in. And 1.44 is actually very similar to 144. Now I've done this enough to know that 144, if I take the square root of that, it's really 12. So if I take the square root of a 1.44, I actually end up with 1.2. And again, this here is a rational number because it terminates. Now for the next part, I have the square root of negative square root of 5. There is no number that I can multiply by itself, like no whole number in that sense. So if you punch in the square root of 5 on your calculator, you are going to get, and it is a negative, so it would be 2.23606,798, and it continues on. So this right here, this is going to be an irrational because it continues on forever. Likewise, for the last part here, remember when I take the square root of a fraction, it's really the square root of 4 divided by the square root of 9. The square root of 4 is 2, so I'm going to go plus or minus 2. And the square root of 9 is really 3. So 2/3, although the decimal repeats, it can be written as a fraction. So this here, I'm going to say is a rational square root. Now again, as I mentioned, okay, you're going to want to memorize some basic perfect squares. So what do I mean by perfect squares? Okay, if you look at your consecutive integers here, okay, I have 1, 2, 3, all the way up through 6. So I'm looking at what I call my perfect squares right here. Well, what that means is 1 squared really equals 1. When I come down here, now I have 2 squared. Well, 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36, and so on. So if you can memorize, and I would say you should at least know 1 through 10, if not even maybe 1 through 20, okay? But I would say if you know 1 through 10 perfect squares, you should be sitting pretty good. Okay, so what we can do is we can use these perfect squares to kind of help us estimate square roots of non-perfect squares. And I'll show you what that looks like here in this next example. So for example 3, it says between what 2 consecutive integers is the square root of 28.34? So in my head, I know that 25 is a perfect square, and I know that 36 is a perfect square, because 25 is really 5 squared and 36 is really 6 squared. So somewhere in between 25 and 36 is where the square root of 28.34 falls. Okay, so what that tells me then is if I take the square root of 25, that's going to give me 5, and the square root of 28.34 is going to fall somewhere in there, and the square root of 36 is 6. So I know that the square root of 28.34 must be in between 5 and 6. And if you really want to know, it is 5.3235, and it continues on. Okay, and then our last application of this is going to help us use, or help us be able to find distances. Okay, so it tells us that the formula for the distance, d, and d is the hypotenuse of that triangle, Okay, gives the length of each wire for the towers shown. We're going to find the length of the wire if x equals 12 feet. Okay, so what we're going to do for this problem is we are just going to plug everything in that we know. So we end up with a square root of x squared, so I have 12 squared plus 2 times 12, and that's going to be squared. So when I simplify this, I have the square root of 144 plus 2 times 12 is really 24. Oops, sorry, I have 2 times. If I do my order of operations, I have to do 12 squared first. So that's really 2 times 144. And then I have the square root of 144 plus 288. And now if I simplify that, 288 plus 144 is going to be the square root of 432. Now, if you find yourself memorizing some of these perfect squares, I personally know that the square root of 400 is a perfect square, just like the square root of 441 is a perfect square. And so because 432 falls in between, I can say the square root of 432 falls in between 400 and 441. The square root of 441 is actually 20, and the square root of 441 is 21. So I know that my distance is somewhere in between 20 and 21 foot. Okay, and if I do take the square root of 432, we're going to find that D is approximately equal to 20.78 feet. Okay, please let me know if you have any questions. Otherwise, I will see you guys in class.